Somewhere beyond NATO's eastern monitoring perimeter, a low, almost silent object cuts through the sky. No jet engine roar, no missile plume, just a faint electronic signature briefly flashing across radar screens before disappearing again. This isn't a fighter jet. This isn't a cruise missile. This is something far more difficult to track, harder to stop, and increasingly central to modern warfare. Russia's latest generation of unmanned aerial systems. Over the past year, NATO intelligence agencies have quietly shifted priorities. Satellite time, once dedicated primarily to armored formations and missile deployments, is now being reallocated. The focus has changed. The question is no longer how many tanks Russia can field or how fast its missiles fly. The question is how effectively Russia can see, strike, and overwhelm using drones operating in coordinated networks. This matters because drones are no longer just support tools. They are becoming the backbone of battlefield decision-making. And NATO knows that whoever masters this layer of warfare gains a decisive advantage long before traditional forces ever engage. Russia's latest generation of unmanned aerial systems did not happen overnight. Early systems were limited, slow, and heavily dependent on foreign components. But operational experience forced rapid adaptation. What NATO analysts are seeing now is a mature ecosystem rather than individual platforms. Surveillance drones feeding data directly to strike drones coordinating with electronic warfare units, electronic warfare drones shaping the battle space before any weapon is released. The most concerning shift for NATO planners is not speed or range, it is integration. Russian drones are increasingly operating as part of a single digital kill chain. Detection, identification, targeting, and strike are happening faster than traditional air defense structures were designed to respond. This creates a timing problem. NATO air defenses are extremely capable, but they rely on layered responses. Sensors detect, operators classify, command authorizes, interceptors launch. Against manned aircraft or ballistic threats, this system works well. Against swarms of low-cost, semi-autonomous drones operating at multiple altitudes and angles, the timeline collapses. Some drones fly high and act as persistent eyes in the sky, mapping radar coverage and identifying gaps. Others fly low, hugging terrain, using visual navigation instead of satellite guidance. Some carry explosives, others carry electronic payloads designed to confuse or overload defensive sensors. Individually, they are manageable. Collectively, they become a saturation problem. NATO is watching closely because these systems exploit a fundamental imbalance. Defensive interceptors are expensive, drones are not. Every interceptor fired at a drone is a cost exchange that favors the attacker. Even if the defense succeeds tactically, it loses strategically by draining inventory. Another area drawing intense NATO attention is electronic resilience. Russian drones are increasingly designed to operate in environments where GPS is degraded or unavailable. Navigation relies on inertial systems, terrain recognition, and visual matching. Control links are shorter, harder to detect, and in some cases unnecessary once the drone is airborne. This challenges a long-standing assumption. Western doctrine often assumes that electronic superiority can neutralize unmanned systems, jam the signal, and the drone fails. What NATO is discovering is that newer Russian designs assume jamming as the default condition, not the exception. This shifts the defensive burden back onto physical interception. Guns, missiles, and directed energy systems must now do the work that electronic warfare once handled. And scaling those defenses across wide areas is both complex and costly. There is also a psychological dimension NATO cannot ignore. Drones change how space is perceived. Constant overhead presence creates pressure on decision-makers. Command posts must move more frequently. Air defenses must stay active longer. Crews experience fatigue not from combat, but from continuous exposure. From a strategic standpoint, Russia's drone doctrine emphasizes persistence rather than shock. Instead of one dramatic strike, the objective is continuous pressure, continuous observation, continuous probing. Over time, defenses reveal patterns, weak points emerge, the battle space becomes transparent. This transparency is what NATO finds most unsettling. Traditional deterrence relies on uncertainty. If movements can be tracked in near real time, maneuver becomes riskier. Concentration of forces becomes visible. Surprise becomes harder to achieve. NATO responses are already underway. Member states are accelerating counter-drone programs, integrating short-range air defenses, and experimenting with layered sensor fusion. Artificial intelligence is being introduced to speed up threat classification. Laser systems and high-rate cannons are being tested to reduce interception costs. But adaptation takes time. Training crews, integrating systems, and standardizing responses across multiple nations is a slow process. Meanwhile, drone development cycles are short. Software updates can change behavior in weeks, not years. This creates an asymmetry NATO planners take very seriously. Hardware-centric defense systems face software-driven threats. The side that can iterate faster gains the advantage. Russia's approach reflects this reality. Instead of betting everything on a single revolutionary platform, it is refining many small systems simultaneously. Incremental improvements, faster data links, better autonomy, improved resistance to countermeasures. Each update alone is manageable. Together, they compound. From NATO's perspective, this is not about one country or one conflict. It is about the future character of warfare. Drones represent a shift away from platform-centric dominance to network-centric pressure. Control the network, and individual losses matter less. That is why NATO is studying not just the drones themselves, but how they are used. Launch patterns, recovery methods, communication behavior, the human-machine relationship behind the screens. Because the real weapon is not the drone, it is the system that connects sensors, decision-makers, and effects into a single continuous loop. As this evolution continues, the balance between offense and defense is being recalibrated in real time. Not through dramatic battles, but through quiet adaptation, industrial output, and algorithmic refinement. This is the competition that defines modern military power. Not who flies faster, but who learns faster. Not who builds bigger, but who connects better. And that is why NATO is watching Russia's latest drone technology so closely, because the next major shift in warfare may not arrive with an explosion, but with a signal that appears briefly on a screen and then vanishes. If you want clear, factual breakdowns of the technologies shaping modern military power, subscribe to the channel and stay with us. New deep analysis videos are coming regularly, focused on how strategy, technology, and industry are reshaping global security.